Hey, hello world, my name is Prithviraj and welcome to my YouTube channel Bionic Bee. On this channel, I'll be presenting my ideas for all the guys who really enjoy learning data science and AI. My goal is to inspire you guys to get creative in the field of AI and have fun trying new ideas and reading research papers. Be sure to hit that subscribe button down there so that you don't miss out on any of my videos. Thanks for watching. So hello guys, today's topic is going to be max pooling. So max pooling is really an interesting topic in convolutional neural network. It is generally used to reduce the size of input features. Apart from that, it is having a very important role in convolutional neural network, which we are going to discuss in this video. So in the last video, we have discussed about the problem of deeper layer for a 400 cross 400 image. So just to iterate over it, if we have a 400 cross 400 image and we want to reach image size of 1 cross 1 with a stride of 1 and padding 0 and using a kernel of size 3 cross 3, we need to do 200 convolutions to reach a pixel size we need, right? And 200 layers are going to be really heavy for a model to train because those are having huge number of parameters inside. To reduce the number of layers here, we can use max pooling. So max pooling is a technique used in convolutional neural network to reduce the size of input feature maps by taking the maximum value of a certain window size over the feature map, right? So feature map is also known as channels, what we got output from our convolution, right? Now in this image, you can see we have a feature map of 4 cross 4 and we are using max pooling and the feature map has reduced to 2 cross 2. So max pooling is having two features inside. If you are using PyTorch, you can see the kernel size, and the kernel size in max pooling generally can be 2 cross 2. Most of the time we use 2 cross 2 as a kernel size, but there are use cases where we can use higher number of kernel size as well. And the stride what we are going to use as 2 in this case, right? So if you are going to use a 2 cross 2 kernel in max pooling, so the specific color assigned to each and every pixel, let's say this is the max pooling we are doing on top of these 4 pixels, we are going to find out the maximum out of these 4 pixels, and that is 8 in this case. In this image, the maximum out of the 4 is 9. Similarly, here it is 6 and here it is 7. So if you can see, the feature map size here was 4 cross 4 initially, and after using max pool it has reduced to 2 cross 2. So what exactly is happening when we are using max pooling? So this information is retrieved from MNIST dataset, where you can see I have an image of size 28 cross 28 and this is representing 8. And when I have used a max pooling, I have reduced the image size to 14 cross 14. And I have the same information which we had in the first image. The size of the feature map has reduced because we have used max pooling. So when we'll do convolution on a less size feature map, the number of convolution operation what we are going to do is going to reduce. Hence the CPU and the GPU utilization also is going to reduce in that case. You can say that max pooling is a technique of sampling as we use in machine learning. But this sampling doesn't lose any information. Most of the information here are intact, just like we see. One important information what we should know about max pooling, that if we apply max pooling again on this top of this 14 cross 14 as output what we got from 28 cross 28, it might remove more features, right? In that case, if we keep on applying max pooling, at the end it is going to remove all the important numbers or the features what we need, and we are not going to have anything. So max pooling, while using the model, we have to be very, very careful in which layer we are using. Best practices for max pooling in the research paper has written that the max pooling we should use during the initial layers, and we should not use max pooling during the last layers where we are trying to extract the amplitude of a specific feature or a specific class we have extracted. Like the whole operation what we have done from the beginning to the end, we should keep it intact and we should not add max pool and remove the information out of it. Apart from reducing the feature map, it does add a very important information which is known as invariance. What is invariance? MaxPooling introduced shift invariance, rotation invariance, and scale invariance. So if you look at this first row, we have a straight line over here in the fourth column, and we have a straight line over here in the third column, and we have a straight line over here in the second column. If you see, if we try to do a max pooling, like we try to get the maximum out of a 2x2 area, and we try to find out the output, we will see that the max pooling is going to give us almost similar result in this first two case, but a different result in the second case, right? If I'm going to use max pooling in this case for the specific image, so if I take this image and try to do max pooling on this area, I'm going to get a single pixel. Then if I do it on this area, I'm going to get a green pixel. And if I'm going to do it on this two area, I'm going to again get a single red pixel. So if I just draw the whole picture, it is going to have something like this, right? So if you see, it just replicated the same kind of image. Now if I do max pooling on top of this, you see that we are going to get the same type of image here, right? And then if we do max pooling on this, it is going to give something different. In this case, it is going to give us an image like this, where the first one is with the green color. But if you look into this very carefully, if we again do max pooling on this two image, then we are also going to get the same image out, right? So max pooling introduced some shift invariance in the first part, right? Now max pooling, if we do the same operation over here, then also we are going to get similar result in each and every layer. And if we convolute, if we do max pooling for the first and second column twice, then we are going to get the result same as the third one. So what does this invariance means? So it means if your object has moved a little bit, if you have max pooling in our models, then still it is going to detect. Let's say we are doing a face detection model, and if you have moved your face towards left a little bit in the training, all the training data you have done is actually facing towards left, or I can say the most of the training data, your face is facing towards the left most of the time. In that case, if you introduce max pooling, if you look straight to the camera and we try to offer object detection, it will be able to detect, because max pooling will introduce a shift invariance even if you have moved your face, because it has understood the pattern of your nose or the eyes, the pattern of your eyes or the eyebrows or the face. Even if your face is moved a little bit from left to right or maybe in some other position, it will be able to detect it. And that's why we should use max pooling. The information what we should take from this video is max pooling is used to reduce the size of feature maps, and we reduce it because it will help us doing the computation faster and in the optimized way. We will reduce the computation and we can utilize it in some other steps. And the second thing, max pooling introduced shift invariance, translation invariance, and a rotational invariance, right? Which is going to help your model generalize more. So thank you so much for watching. Have a good day.